Hello, everyone, and welcome back to vBrownBag Commitmas, or Commitmika, Commitza, whatever you celebrate. Happy holidays. And tonight we are talking about getting, get it, G-I-T, out of a mess with Katie Sylor-Miller. A few show notes before we start, as always. Get in on the conversation. You can at vBrownBag us, at vBrownBag Latam, at vBrownBag EMEA, and of course Twitter hashtag vBrownBag. And I'll be following that tonight as well as hashtag Commitmas. So feel free to ask me questions, ask Katie questions via either the GoToMeeting or via Twitter, and I'll be following that. Also, keep in mind, APAC every other Thursday, 10 p.m. NZT, of course. EMEA, Tuesdays, 7 p.m. BST. LATAM, that's Latin America, Thursdays at 7 p.m. PDT. And, of course, the U.S., which you may be tuned into already, at 7:30 p.m. Central. As I said, our guest is Katie Sylor-Miller. I am Lauren Malhoy at Malhoy, and I forgot to change the picture there, so it's a picture of Adam Eckerly. But I assure you, I am not Adam Eckerly. I couldn't be that great, so I should have changed that picture. My apologies. But also, of course, with Commitmas, there are a lot of prizes here. Prizes for the end of Commitmas. And this ends, I believe, at the end of December. So take a look at the prizes. I can't win these, unfortunately. I wish I could, but there are a lot of cool prizes. So check those out. Make sure you are watching. And, of course, follow us on GitHub. And Katie's going to talk a little bit more about that. Clone and star the repo noted here. I'm not going to read off the long thing. Check out the website, vbrownbag.com, or watch our YouTube videos. And of course, we're on Slack at commitmas-invite.herokuapp.com. And with that, Katie, I am going to... Oh, I'm seeing there's no picture. Katie, can you see my picture?
No, I can't.
All right.
Oh, there we
How
go.
about now?
Okay. There
Well,
we go.
there's no picture because I didn't share it. So that makes a lot of sense. But that's okay, you guys. Let me just, real quick, I'm not going to read through the whole thing again. I'm a novice, apparently. Here's the quick notes. Here are the prizes. And here are the websites you can check out. And with that note, I'm going to pass it over to an expert who hopefully does a way better job than I did.
I don't know about that.
Here you go, Katie. I'm passing the ball to you. Please
All
save me from my own problems.
Cool. All right. Hopefully y'all can see my screen.
I can see it.
Awesome. So as Lauren said, hi, I'm Katie Sylor-Miller. I'm a senior software engineer at Etsy.com, where I work on the design systems team. And I also made this website called ohshitgit.com,
Oh
which
my
is kind of
gosh.
funny, the
I'm
story.
sorry. I'm sorry to interrupt. That's amazing. Go ahead.
um, so, so I don't know how the rest of you have been learning Git or have learned Git, but I learned it very poorly by having someone kind of stand next to me at my desk and give me a list of commands to run. And I had no idea what I was doing or why anything worked or what these commands meant. And I'm not really ashamed at all to admit that after, a couple months of that, I still felt like I was an idiot and was questioning why I chose web development as a profession. And that's kind of where ohshitgit came from, is I started keeping this note file, and I called it gitshit.doc. That was a list of like shorthands and ways that I had gotten myself out of these different messes. And basically the point of that whole story is to say that, like, if I can learn Git, then you can learn Git too. If you're feeling stupid trying to figure out what the heck this thing is, how it works, you're not alone, because I am right here with you. So let's get started. Let's talk about what we can do when we get into a mess in Git. And really, I think the first thing is to avoid getting into a mess in the first place. Out of everything that I've learned in the last year and a half, this I think is the #1 piece. And I really think that in order to avoid getting into a mess in the first place, you really need to understand some of the fundamental structures and concepts in Git and how they work. So things like, what is a commit? What is a branch? What is the head? What are the different environments that we're going to be working in? So I think we're going to start and kind of go over some of these fundamentals, and hopefully these concepts will be the epiphany for you that they were for me. So let's start out diving deeper into commits. So what's in a commit? Each commit contains, it's not just the file or the files that have changed. It stores a snapshot of the entire tree of files in your repository. It also saves the information about who made the change, when it was made, your message that you provide that describes the commit, and then it has a pointer to the previous commit. And I put at the bottom, this is a little bit of an oversimplification, but that's basically the idea. If you want to learn more, there's a link included there that you can go to where someone wrote up a really awesome detailed explanation of commits. So what's in a commit? What happens is after you make your commit, all of these pieces of information are run through an SHA-1 hash, and that generates a unique 40-character hash, which is the reference to that specific commit. Now this is really super powerful because, if you think about it, because of the information that's getting included, if I made a change to a file and someone else makes the exact same change to the exact same file, our commits are going to be totally different and unique. So we'll always be able to pull them out individually. So this is what some commit hashes look like. If we were looking at the history of our project, it looks like this long string of randomly generated characters. A fun fact about commit hashes is because of the way that they're generated and the guarantee of uniqueness, you can usually only need to reference the first 4 to 7 characters of the commit hash in order to reference it. But some really big repos, like the Linux kernel, which was basically what Git was created to manage, was the Linux kernel, you need to use 11 to 12 characters to determine a unique commit hash. So the bigger it gets, the longer you have to use of the shorthand to reference it. All right, so branches. What is a branch? So the branches really are the connection between all of the commits in our repository. They tie together the history of our project by creating this chain that's linked together chronologically. Every repo starts out with a single branch, which is called master, and then there can be multiple branches made of that repo, which are essentially copies of the master branch. Now, I came before Git. I spent probably 8 years using TFS and SVN. And if you're coming from that situation, you probably think branches are this giant hassle. They're a pain in the ass. You have to go bug some grumpy guy who runs the repository and beg for a branch because there's all this configuration involved. Well, Git is not like that. All you have to do is type a command and you have a new branch.
Katie, can I stop you? For those of us who don't know, not me, of course, but maybe other people, what is TFS and SVN?
TFS is Team Foundation Server, which is a Microsoft version control system, and then SVN is short for Subversion, which is another version control system. There's a couple other ones out there, but those are the two that I've used in the past.
Cool, thank you.
No problem. All right, so now let's get real computer sciencey. So under the hood, branches are analogous to this programming data structure called a linked list. Although, again, this is kind of an oversimplification. So if you didn't study computer science, a linked list is a way to connect in sequence a collection of data. Each data point is called a node, and each node contains two things. The data, which in this model is kind of represented by the blue box, and then a reference to the next node in the sequence, which is the white box. So the data in our commit, when you think back on this a couple slides ago, we talked about the information that's included in a commit. That blue box of data is sort of, you can think of it as though it was the snapshot of the entire repo, who made the change, when the change was made, and the message. And then the other half of each node is a pointer back to its parent commit, so the last commit in history before this one. So that means our first commit, it doesn't have a pointer since it's the very first commit. It doesn't have a parent. The second commit has a pointer back to its parent, the first commit, and so on and so forth down the line until we get to our most recent commit. So like I said, this is kind of an oversimplification, and it's actually a little bit of a lie. I'm sorry I've been lying to you. Branches are not actually a linked list. Branches are a single, what's called a symbolic reference to a commit. So our master branch is really a symbolic reference, or like a pointer, to a specific commit hash. And then once we know that reference, we can follow back through each step in time from child to parent to reconstruct the history of our branch. So when we're talking about branches, you can kind of think of them as being this structure of connected nodes, but really all it is just it's like literally a text file that has a hash inside of it. All right, so working in a single branch, great, but branches are really powerful, so let's see what happens when we create a new branch by running git branch, and we pass in the new branch name, new branch. So this commit creates a new branch, which again is just another pointer that points to the same commit as master. In practice, though, what this really means is that we have an entire copy of the master branch that shares the same history and contains the same files. Under the hood, it's really references to the same commit, but as you're using it, you can kind of think of it as being a complete copy. So now if we want to start adding commits onto our new branch, we need to learn about another fundamental, which is the head. If you've played around in Git at all, you've probably seen this. It's always uppercase like this. So what is the head, really? Well, the head is another kind of symbolic reference. So the head, in this case, points to the top of your currently checked out branch. So the reason why our new branch was created as a pointer to the last commit in master was because our head was pointing to master, and when you run the create a new branch command, it adds a new pointer to where the head is currently pointing. So now if we added new commits, they would go onto master, because head is sort of determines where you are right now and where all of your actions are going to affect. So if we check out a new branch, now our head reference is pointing to new branch, which again in turn is another symbolic reference that points to a commit in history. So from here on out, any commits are going to be added with their parent set to the tip of new branch. So here I added a new commit, and again, our new commit is created. Our reference to new branch moves to point to our new commit. Our head points to new branch, but the difference in how we're starting to branch, as you can see, is that the pointer for master hasn't changed. It's still pointing where it used to be. So say, we work on a distributed team, and well, we've been adding commits in our new branch. Someone else has been adding their commits into master. So this is where the tree is like branching, and this is really the fundamental, like, most powerful thing that happens in Git, is that it gives you this ability to have a shared history, and then when you are branching out separately, you can go back and find that shared point in history and use that to determine what has changed between your different branches. All right. And also, I've been lying. I'm sorry, I keep lying about what branches are, but
Katie, I don't know how we're going to trust you from here on.
I know. I'm sorry. It's just like it's easier to build up the concept slowly. Because if I had showed this slide to you at first and said, okay, so a branch is a directed acyclic graph, like you would probably just hang up and run away screaming, because this is kind of bonkers and terrifying. But this is really what
before
this
you
is
go.
really what history and Git is a directed acyclic graph, or a DAG.
Before you go too much into that, we do have a question. So can you have multiple heads?
No, there's only one head for each repo at any given point. And I'm going to get into this a little bit later, but the reason for that is that the head represents your current state. And the great thing about the head is that the history of where the head is pointing is actually tracked separately in history, which allows you to move back and forth in time. If you make a mistake, you can like go backwards. If it was, something that happened when you checked out a branch like 5 minutes ago, you can go back to before any of that. So it's really good that there's only one head. We wouldn't want more than one.
Yeah, well, that's what the ladies say. No, I shouldn't have made that joke. I'm sorry. Keep going. Just move on.
That's okay. So the final kind of foundational concept I want to talk about is remote versus local. So these are like the two different environments where you're actually interacting with your Git repos. So the remote/origin is typically like a GitHub server. It could be a Bitbucket server. It could be something that you have installed only for your company. But it's basically like the server where all of our shared repositories are stored. And this is usually considered like the single source of truth. The hub, and then all of your distributed teammates are like the spokes around the hub. So remotes are typically installed bare, which means that you can't directly modify the code stored there. So like on your local machine, when you're interacting with a Git repo, you have your local copy, and then you have these 3 different workspaces. Remote doesn't have those. So this was like a big epiphany for me, this is why if you're going through a workflow where you want to push something to remote and make a PR for it, that's why you have to jump out of the command line and switch over into the GitHub UI, is because you can't directly modify a bare repository. It can only be done through a web interface. So. All right, so when we get into our machine, there's 4 sub-environments. There's your local copy of the repo, which is basically contains all of the history of the repo and all of the branches inside of it. There's their staging area, or sometimes it's called the index. They're both used sort of interchangeably. Now this is a snapshot of all of the changes to the current branch that you might want to commit. Now, one thing that's really important to understand about staging is that it's not just the files that you've changed, that it's a copy of all of the files in your repo. So you can sort of think of it as like a duplicate of everything in your C/whatever directory you installed your GitHub repo into. So this kind of explains why, if anyone has run into this, I used to do this a lot. I would make some changes. I would add the file to staging. I would continue to make some more changes in that same file. I would run commit, and it wouldn't capture my changes. And the reason for that is because it's a snapshot in time. It's not like a list of files. You're not saying add this file to my list of things I want to change. You're saying take a snapshot of it.
So each time you make any changes, you have to do a commit on your local machine.
Well, each time you make changes, if you want to commit it, you need to add it. So the staging areas, I'll get into this a little bit more, a little further down. But
yeah, go
staging
ahead.
areas saying this is all the stuff that I want to eventually commit. You don't have to commit it.
Gotcha.
Um, the workspace, so now this is where you're actually making all of your changes to your files. So this is analogous to the physical directory on your machine where the stores are, where the files are stored on your disk. And then finally is the stash, which is like a place to store, or in TFS it was always called shelving your changes. So it was basically a way to like say, I made some changes, I'm not ready to commit them yet, but I want to maybe save them and come back to them later. You can add them into the stash, and then you can do whatever other work, and then you can pop them out of the stash. I'm not going to go into like a ton of detail on the stash today, but it's really nice because the stash persists across all branches. So a lot of times what I'll do is I'll like start working on something and realize I'm still in master and I forgot to make a new branch. So I will stash the changes, you know, create a new branch, unstash the changes to pop them out. Hello?
I'm still here.
Oh, okay.
Yep.
Sorry. So next, history. So let's look at how we view our history and then how some different ways that we can change the history of our branch. So to see the history of our branch, we run git log. So what git log does is, you know, it starts at the most recent commit, although you can pass in parameters that will start at whatever commit you want to give it. And then it follows all of the links backwards to the parent of that commit and so on until the beginning of time, and gives you information about that commit. So you can see like the unique hash, the author, the date. So this is just like I pulled down a local copy of the public jQuery repo. So these are where the last 3 commits to jQuery. I think I mentioned this before, but something that I think is even more useful is what's called the ref log, which shows you a history of the head. Now the head, basically every time you're taking an action in the repo, a new entry gets added into the ref log of where your head is. So if you look at the list, you can see I merged a branch, I checked out a new branch, I committed, you know, going all the way back to when I initially cloned the repo. So I can reset back to any of these points in time, which is great because this is like the foobar. Like I completely screwed everything up. You can, if you pull up your ref log, you can see, okay, before I checked out this branch, everything was good, and you can completely reset to that point in time, which is like awesome. All right, so how do we move around in our history? So git checkout takes you back to a specific point in time. However, checking out a previous point in time this way, it's not going to change any of your history. It puts you into this read-only state called a detached head. Now, this is something the first time I saw it, I was like, I think I panicked because I was like, oh my God, what's going on? But basically, when you're in a detached head state, it means that your head is not a symbolic reference anymore. You're not pointing to the tip of a branch. You're actually pointing directly to a commit by referencing its hash. So this can kind of happen if you check out a commit that's not at the tip of your branch, which you might want to do because maybe you just want to go and look at what the state of your repository was like at that point in time. Or you can get into the state if you check out a remote tracking branch, which is kind of the way that your local machine is synced with your remote branch. And the way that you can fix it or get out of the detached head state is to actually check out a branch, or if you run git branch to create a new branch from that state, then it your directed acyclic graph gets a new leaf node added onto it, and you can continue to work from that state. But if you have a detached head, you can't add any new commits because there's nowhere for it to get added to. All right, so The main point I want to make tonight is that you're better off trying to avoid messes in the first place, but there's really two main ways to fix your mistakes once you make them, and that's reset and revert. So again, reset takes you back to a previous point in time. Remember our old friend reflog? Like you can, if you let's see, so you can see each point in time it has that head at open bracket and then a number close bracket. So that's one way that you can reference different points in history, is by using get reset head at and then whatever number, index for that point in time. Or you can use what's called tilde notation, and that's basically saying go back X commits in time. So if you don't, if you want to go back 3 commits, then you can say get reset head tilde 3. Or you can do get reset and pass in the hash for a very specific commit, and it'll take you back to that point. One thing to be aware of, though, of reset, as with anything that changes your history, you can only do this if you haven't pushed this branch or your changes to this branch out to a public repo. Because if you think about it, like once somebody else has possibly pulled down a copy, if you're rewriting the history, then like how are they ever going to recover? Because they'll have all these extra commits on their local that no longer exist in your local or in the remote repo, and because the connections between the commits has been lost, Git doesn't know how to recover from it. So reset you should really only do for changes that you haven't pushed out yet. There's 3 different ways to reset, and the difference between them is what they do to your files when you reset. So when you reset soft, what this does is it takes you back X number of commits, it undoes those commits, and then it leaves those changes from the affected commits in your staging environment. So your staging environment is like where you're saying, I want to commit this. If you say like the problem you're trying to fix is that you accidentally committed a file that you didn't want to include, you would do a get reset soft, do a get reset hard on that file, which pops it out of staging, and then you could redo your commit. The default is mixed. So what mixed does is it leaves the changes in the workspace. So you wouldn't have anything in staging. It would leave all of your changes in the workspace, so you could then decide what you want to, if you want to commit anything, you can add it back into staging. Or doing a hard reset discards all of your changes. So pro tip, this is if you ever find yourself in a situation where you maybe have a bunch of files in staging, maybe you have some stuff in your workspace that you've changed, if you run get reset hard, then that clears out everything, throws away everything. You might, this is destructive, so it might not always be what you want, but I find myself using this somewhat frequently. All right, so then reverting. Reset is great, but what do you do if you've already pushed a commit out to a public remote repository and you want to undo it? Git revert is the answer to that problem. So when you want to revert, you can either pass an explicit commit hash, or you can say, I want to revert the last X commits by using the head tilde notation. And what a revert does, unlike reset, is it doesn't actually take you back in time and unstage all of your changes. What it does is it creates a new commit that undoes all of the work and the changes that were done in that commit. Essentially what it does is it creates like a reverse patch. So you can like revert a commit that's sitting in the middle of other commits. Like if you know that you introduced a bug in a specific commit, then you can revert just that commit. But something to be aware of is that if a later commit modifies that same file, then you're going to have a conflict that you're going to need to resolve. You can also use a couple of different ways to revert multiple commits. You can use Tilde references, you can use the two dots, so like git revert head tilde 3 dot dot head. That's saying I want to commit the last, I want to revert the last 3 commits. Or you can list them out by either head references or commit hashes, and then it will do each one in order from newest to oldest. And the final thing about reverting is revert automatically, when you run it, will actually make the commit that undoes the work for you. If you don't want it to do that, then you can pass in the no commit flag, and this will just prep everything for you in your workspace. You can look it over, and then if you need to change anything, you can before you actually do the manual commit. Awesome. All right, so let's move into workflow. So let's go over a very simple branching workflow and take a look at how we do things like syncing our local with our remote. So this is a really trivial example, and we're going to just use master. We're not using another branch, but this kind of helps to understand some difficult concepts. So here we are back with our view of our different workspaces. So let's say I make a change to foo.php in my workspace. I run git add, which takes a snapshot of the changed file and adds it to my staging snapshot. So again, workspace is where you're doing all of your work, and staging is your way of saying I'm ready, or I'm ready, I think I might actually commit this. Then when we're all done with all of our work, we run commit. Now this creates a new commit on our local copy of the master branch. Because my head is pointing at the tip of the master branch, my new commit gets added with the tip of master as its parent commit. So then the pointer for master gets moved up to our new commit. That's now the tip of master. So now I want to run push to copy my change out to my remote server. And it happens really easily because our commit's parent is also the tip of the master branch on the remote. It's what's called a fast forward. So the push goes through super easily, there's no conflicts. And then now, after we've pushed, the head of master in both places is pointing, or excuse me, the tip of master is pointing to the same places, and we're back in sync. But it's usually really not that simple when you're doing distributed development. Like, typically when you're working with other people, when you're ready to push out your changes, the remote actually looks more like this. Like there's 4 new commits that have other people have added into master that are not reflected in my local repo. So if I try to do a push at this point, Git's going to reject my change because it isn't a fast forward. You could force push it, but what that would do is it would like discard everybody else's commits, and you don't want that. So what we need to do is we need to get our branch up to date. So I think this is really the #1 rule of avoiding messes in Git, is to always stay up to date. The more out of sync your local gets with the remote, the harder that it's going to be for you to eventually like merge everything together. So how do we get everyone else's commits and our new commit onto a branch together? So first, to really kind of, I'm sorry, I know I keep lying to everybody, but another little white lie is like, so there isn't really a direct connection between what's happening on your local and what's happening on the remote server. You know, remember, remotes are bare, so we can't directly modify them. So the way that Git kind of gets around this is you have what's called a tracking branch that lives on your local. And like all branches, it's just another symbolic reference to a commit. And this is represented by origin/master. So that's saying this is the tracking branch. My remote is called origin, and my branch is called master. Tracking branches, we can't directly modify tracking branches. If you try to check out a tracking branch, you're going to end up in a detached head state because you can't touch it, you can't modify it. So first thing we need to do is we actually need to update our local tracking branch, and we do that by running git fetch. Git fetch, when you run it like this, it updates all of your local tracking branches. But I mean, I don't, you could pass in a specific branch that you want to fetch, but why would you don't really need to. So what fetch does is it creates one of our trees where now it's not just master that's master is no longer like our nice little straight line of commit histories, because origin master actually points to a completely different parent commit than our master. So we can, now that we have this like updated view, so we know our origin master looks like this, now we run git merge, and what that does is it merges our changes into the master branch. So we run our new merge commit, and a merge commit is a little different in that merge commits have more than one parent commit. In fact, you can actually merge like multiple branches together at the same time, although I don't really know why you'd ever want to do that because that sounds like hell. But so this, like the merge commit actually keeps our changes and ties everything together by creating this little kind of bumpy thing in history off to the side. And then
is
now
bumpy thing's the technical term.
Yeah.
Good.
Bumpy
Okay.
thing
Just want to make
is
sure.
the technical part of your directed acyclic graph. No.
Cool.
So that process that we just followed, running git fetch and then git merge, is actually what happens when you run git pull. So git pull just does all of those steps simultaneously, and we end up in the same state as if we had run the two commands individually. Right, so now that we've incorporated all of our branches together, we can push everything out to the remote. This is a fast forward, so everything goes nice and smoothly. The remote master is updated with our new commit, and then the pointers move up to the tips of both branches, the remote master and then our local tracking branch. So this, this got the job done, but sometimes you might not want to have this kind of branching history. Like, imagine in a large distributed code base, like how quickly, if somebody else branched off of another commit, they have a little bumpy thing out to the side. I mean, there could really be dozens of these branches overlapping and intersecting. So personally, I prefer rebasing. I think rebasing, you end up with a nice linear history of commits. It's easier, like if you use a visual Git tool that shows you these branches as little dots, like it's really hard to understand those unless you have a nice linear commit history.
And are you going to explain what you mean by rebase?
I am, yes.
Perfect.
So let's rewind back. So this is we just ran fetch. We have our commit to master. There's a bunch of new stuff in Origin that we need to take into account. So we run rebase against Origin. So what rebase does is it's telling our master branch to rewrite its history using Origin master as its base. So what does rewriting history mean? So our commit gets detached from its place in our master branch. So basically we cut off its parent commit. The diff gets saved in a temporary file, and then the tip of our local master branch gets moved up to the same commit as the tip of origin master. Then Git will apply the diff for our new commit on top of master. So it basically like redoes your changes at the new point in history at the tip of the branch. If you have multiple commits in your branch that are different, it'll apply each one individually, like in chronological order at the tip of the branch. So this is what's called like rewinding. So basically here, like we've ended up in the same state where our changes are on the most recent version of master that's coming from our remote, but it has this like really nice linear history. So git pull with rebase, just like git pull, does those two things all in one. Git pull -- rebase runs git fetch and git rebase at the same time. A pro tip, so we have this at Etsy actually. We have an alias set called rpull, which does pull dash dash rebase. So you could run a pull which does a merge, or you could run an rpull, which does a rebase. So there's our nice history. We push. It's another fast forward. Everything is beautiful.
Pretty blue bumpy things.
Yeah, pretty blue bubbles with no bumps, no bumpy things.
Oh, you're right. Yeah, bubbles.
All right, so my next bit of advice to avoid messes in Git is to always be committing ABCs. So why are lots of commits better than making big, huge commits? So commits are super cheap and easy. Like you really don't have any reason not to use them. They help you save your progress over time and make it easier to go back in time. So like how many times have you started working on something and you get it partially working and then you change something else and everything breaks, like all the time. So if you had just paused when everything worked and made a commit at that point, then you have like this point in your history that you can always go back to. Also, like smaller diffs are easier to reason about. So like when you're, typically if you're getting ready to commit something, you would run a git diff. It's going to show you all of the changes that you've made. Like if you're scrolling through these huge diffs and looking at lots of pluses and minuses, like your eyes kind of glaze over and it's really hard to like reason about and, realize like what are the changes you're actually making. And also you have less chance of committing the wrong thing when you're reviewing small change lists. So like it's a lot easier to notice something that doesn't belong in a list of like 4 file names than it is in a list of 10 or 12 file names.
Katie, it almost seems like Microsoft Word via 1995, right? Like save your progress. Don't assume that it's being saved. Do you think that there will be a time where it's just like it will save different versions for us automatically?
That's entirely.
But that could be like detrimental too, right?
Yeah, exactly. I feel like with like, it's funny because at first I was like, oh, like why do I have to add my changes to staging before I commit? Can I just say like I want to just commit what I have? But then like the first time that you've accidentally made a change to a file and added it and committed it, you're like, like this is why there's this control is to stop you. Yeah, it's like to stop you from screwing up. Like yes, it's a little more of a pain in the ass, but like it saves you in the long run.
Right. So be mindful, I guess.
Totally, exactly, yeah. So it's funny you just said that because we were just talking about like committing the wrong thing. Like we're humans, we make mistakes, we commit the wrong thing. It happens. It's okay. It's easily fixable. So obviously, first though, we want to try to avoid this problem. So there's a bunch of things that you can do to avoid committing the wrong thing. One is to set up your GitHub command line to show you, or not your Git, to show you your command line to show you what branch you're on in your command prompt. This like saves my ass all the time. Another thing to do is to be really careful about what files you're editing, and to use git ignore. So git ignore is a file where you can list a bunch of files that you don't want to actually be saved into Git. So like if you have a local version of your config file that sets a bunch of things up for testing for you just on your local machine, like typically we would add that to our git ignore, so then it's not a shared file, somebody's not accidentally pulling it down with your specific like config changes that you need for your local dev environment. Git status is your best friend. I run git status like constantly just to see where I'm at, to make sure that I'm like doing the right thing, that I have the files that I want are changed, that I didn't accidentally like, sometimes it's easy. I use an IDE, and sometimes you like accidentally drag a file into a new folder without paying attention. Like git status is going to show you, and you can easily be like, oh yeah, that's not. I didn't want to I'm going to revert that. I didn't want to do that. And finally, we had talked about this before, like understanding how staging works and the fact that once you add a file into staging, you're just taking a snapshot of the file at that singular point in time, and any more changes that you make are not going to be reflected in the staging area. They're not going to be reflected in your commit until you re-add them. And also, I think understanding that you can unstage files is going to save you. So fixing the problem, though, like if you enter the wrong commit message, git commit amend is great because it lets you basically rewrite the previous commit. And again, like caveat, as with anything, you shouldn't amend commits that have already been pushed out to a public repo because that's rewriting history. Oh, and also a lot of these like are on oh shit git, so if you don't remember them, then that's totally cool. You can just go there.
Hey, Katie, we have a question from the audience. Did I miss merging multiple branches back into the master? So I guess...
No, we're coming to that in a little bit.
Cool. Awesome. Thank you.
No problem. All right, so we're entering the wrong... Forgetting to commit a file, so you can also use amend to like redo your last commit. Basically, you add the file that you forgot to commit into your staging area, and then you run git commit amend. It'll ask you to change the commit message, and then the new commit will actually contain any files that were in the staging area along with what was originally in the commit. This is like another like super useful command that I use quite frequently. And then the final problem is, like, what if you accidentally committed the wrong file into a commit? We use reset head, and I haven't passed anything in. So what that does is mixed. So mixed leaves all of your changes in the workspace. Actually, yeah. Then you unstage the file that you don't want to include by resetting the head and passing in that file name. That takes it out of play completely. And then you redo your commit. And then that basically like rewrites your time, redoes the same commit. You can even change the commit message. All right. So another great way to avoid messes is to always be branching. So if this is generally what's called a feature branch workflow. So when you're using a feature branch workflow, you create new branches off of master, you do your work in those branches, and then when you're ready, you merge all of your changes back into master. So basically, it's like the safety net that prevents you from accidentally committing and pushing buggy code to master. So like at Etsy, the way that our system is set up is our remote master, it basically represents the state of the live website because all of our deployment architecture is built around continuous integration that uses our master repo as its like single source of truth. So it's we use feature branches all the time so that we're not accidentally committing and pushing things up to master and ending up with it out on the live website when we didn't mean to. Using feature branches also makes it easier to like switch between context tasks and to like manage unrelated work. This happens to me a lot. Like for a while, I was one engineer supporting 4 different designers with 4 different projects. So I was constantly like doing a little bit of work in one thing, pausing, checking in my work, checking out another branch, doing a little bit of work. If I was just doing all commits onto master, then I would have work from different streams like chronologically mixed up, and it's really hard to disentangle those. And finally, when you use a feature branch, you can use that to preserve the history of like larger features or long-term work, and you can use branches to share that work with other people in your team. But with a feature branch workflow, again, the big problem is staying up to date. So as the person who asked the question was wondering, so now what do I do when I've got a feature branch and I want to merge it back into master? So you have two choices, merging and rebasing, and to kind of go over this again. So merging, what that does is that adds a new commit. This is to keep your branch up to date. So you're merging the latest of master into your feature branch. So if you merge master into your feature branch, you're adding another commit. And I think kind of the kicker for me is like when you're doing that, if there's conflicts, like you have to resolve conflicts that are being created by other people's changes to master. So when we merge, like our branch is the base, and master gets applied into our branch. So if we changed a file and somebody else changed a file, like we have to figure out like which of their changes is good, is this not good. But if we rebase, again, what we're doing is we're taking all of our commits, we're popping them off, and then we're replaying them on top of the latest from master. So if there's any conflicts that get created, like it's your own code that you wrote. So theoretically, it should be easier to resolve those conflicts because it's code that you wrote. It's replaying code that you wrote. You should like theoretically know what you were doing. But again, like there's some rebasing gotchas and caveats. Like each commit gets applied as a separate patch. So if you're rebasing and you have like 6 different commits, that's 6 different chances that you're going to have to resolve conflicts, which I don't know about everybody else, but I basically do everything all day long to avoid resolving conflicts because that's like literally the worst. So that's kind of something to think about. Again, don't change the public history of a branch or you're going to have a bad time. And then also, some people just really like to keep that commit history of their branches. It's a team preference. You need to kind of talk about it with your team and say, what do you guys think we should do? And go with whatever the team decision is. All right, so if we're going to lean towards a feature branch workflow, we're going to be separate from master for a while, and then you need to rebase against master to keep your feature branch up to date. I highly recommend periodically combining multiple commits into one. This is also useful in some other situations, like if you make 2 commits to master, and eventually you'd like to be able to roll back this feature with a single revert, then you can use rebase to rebase a branch onto itself. So instead of passing in the name of another branch, I pass in my good old like head tilde notation, and I use the I interactive flag. So basically what this is saying is, all right, I have my feature branch. I want to rebase it against itself. So now the I flag opens up this awful rebase dialog, which is like terrifying and horrible. And I could like go through all of this, but it would take a really long time. So if anybody like has questions or needs help with this, then you can totally ping me, and I can give you some more detail. But the main thing to know is like don't panic.
Katie, while you're saying that, do you mind, like if you don't mind people pinging you, will you repeat your Twitter handle again?
Yeah, it's K Sylor, K-S-Y-L-O-R, or also oh shit git is easier to remember. Yeah, sorry about that. I know people are probably like, oh my god, tell me how to do this, but it was like 30 slides. So we would go way over time. We're already going to go way over time.
Yeah, no, I think everyone appreciates that, and I appreciate you giving out your Twitter handle again.
Yeah, no problem. All right, so now we've rebased, we've squashed our commits. Now we can do our regular, like, we have a single commit. If we were to rebase our feature branch against origin master, it would be like a single commit that gets added. So it's way easier to deal with than having it replay multiple commits. All right, so now merging back to master. Now again, this is like a controversial opinion. Some people really want you to keep the history of your branch separate and available at all times. Personally, just with the way that our continuous integration server works, like it's not necessary. It just makes it confusing. So I tend to do a lot of git merge squash instead of a regular git merge. So like, again, a git merge, what it does is it creates a new merge commit that has more than one parent commit, one of which is master in this case, and the other one would be your feature branch. If you pass in the squash flag to merge, what that does is it creates that commit, but then just leaves all of the changes to the files in your staging area, and then you can go ahead and manually create a new commit in master. So like, if I have my feature branch and I want to do a merge squash, what it does is it takes all three of those commits, combines them into one that's added onto master, and then I have to actually manually make that commit. So like if you needed to make a change, which you probably shouldn't, but I don't know. This keeps your history nice and clean. It's, like I said, it's easier to reason about. But again, like, it's totally personal preference. A lot of people would probably be super horrified that I'm telling you this because they want to have that history. Oh, sorry, yeah. So yeah, the squash merging, it combines all the commits into a single change set. It leaves you in the state where the changes aren't committed and you have to make the final commit. But it causes you to lose that historical connection to your feature branch, but that's like a personal decision if you want to keep that around or not. All right, resolving conflicts. So this is really like I said before, everything that I do in Git is to avoid having to resolve conflicts because this is like the worst. So the best thing to do is obviously to avoid creating conflicts in the first place. The way you do that is communication with your teammates. Like sometimes there are cases where you really need to rewrite the history of a feature branch and push it out to master, and I've done it. You just have to make sure that you communicate with all of your teammates who might also have local copies of this branch to say, hey guys, I rewrote my history. Like, everybody stop what you're doing and get latest before you add any new commits, Another thing to do to avoid conflicts is to update your local all the time, keep your feature branches updated all the time, and then periodically squash the commits in your feature branch to reduce the number of conflicts that you're going to have to eventually resolve, like when you're rebasing. Another thing to think about to avoid conflicts is to make sure that you're merging and rebasing in the right direction. So what you want to do is you want to take your feature branch and merge it into master. You don't want to merge master into your feature branch because that creates a new commit in your feature branch. You're merging stuff. If you screw up when you resolve the conflicts, when you then try to merge it back into master, you might have created a conflict you're now going to have to resolve. So like I say, just don't even do it. Do rebase your feature branch against master. So periodically take your feature branch and rewrite its history to take in all of the new commits that exist in master. And something you don't ever want to do is rebase master against your feature branch because that's rewriting history against itself. It doesn't really make any sense. All right, so the problem, conflict markers. I don't know if you can see in the picture, there's like somebody left in their updated upstream and their stash changes and it got out to a live website. This is my friend Fiona's tweet. So how do we fix that problem? So there's this awesome git diff -- check that you can run. It'll check all of the files in your workspace if there's any commit markers, conflict markers, like the brackets and equal signs, it'll throw a warning. It also throws a warning about white space errors I believe. Another pro tip about merge conflicts is Git has this merge tool command that you can use to open up a GUI that's going to help you resolve conflicts. So I use an IDE called PHP Storm. It's by JetBrains. I've used most of their other IDEs, so like IntelliJ, WebStorm, PHP Storm. I think there's also a Ruby one. They have like by far the best like visual diff and conflict resolution UI that I've ever seen. Also, there's one called, I did a little research just in case you don't like have licenses to these things, and there's one called Meld that looks really good, but I have not had a chance to try it myself. And if all else fails, abort. And you can abort out of any operation at any point. If you're in the middle of a merge, get merge abort. If you're in the middle of a rebase and everything goes south, get rebase abort. You can also Control-C if you're in terminal to just completely kill, the process that you're in. It aborts. So there's always like a way to go back and fix something that you accidentally broke. And I think that's important to remember because it's easy to like panic when something bad happens and you're like, I have no idea what's happening. And that's it. So this is like super easy, right? Everybody's like knows exactly what to do to not ever get into a mess. So to recap, how do we avoid our messes and get, because avoiding them is better than fixing them. We first is like understand the fundamentals, like what are commits, what are branches, how is history generated, how do we look at history, how do we go back in history, what are the different environments that we're working with, how are they different, what's our like basic kind of workflow for committing and branching, use tools to help you work smarter, like formatting your command line to show you what branch you're on. I mean, it's amazing to me. I work with a lot of designers, and a lot of them don't do this, and they like mess up all the time. So that's usually my first thing that I tell people to do is if you're on the Mac or Linux, like go set up your dot files. If you're on PC, I'm not sure what you do, but there's a link on the next slide that takes you to a repo that tells you what to do. Another way to avoid all your messes is always be committing and branching. Commits are cheap and easy. They help you to have a point in time to go back to if something gets screwed up. Branches are your safety net that keep you from messing up master, which is particularly important if your continuous deployment is looking at master. Make sure that you rebase and you merge branches in the right direction. And then don't panic because everything is fixable one way or another. So here's some useful links. The visual Git cheat sheet is awesome. That's sort of where I stole the mental model of the remote and then the 4 different environments in your local. If you go to their site, they have that basic setup, and you can click on an environment, and it lists out each command that you can run from inside of that environment and then what effect it has. It's really, really awesome. Obviously, OSHA Git. If we're looking at like tutorials or things online, I personally have found that the Atlassian set of tutorials are really good. They're just the right mix of like using real human language and actually explaining to you what's going on. Especially they're more like advanced tutorials. And then finally, A Book Apart has this book called Git for Humans. I've read it. It's really, really good. It's also, it's sort of directed mostly at people who are maybe not super comfortable or familiar being, if they're not like a software engineer every day. But like he does such a good job of just explaining things in ways that everyone can understand, no matter what your background. And that's it. Thank you. Hopefully we all have some sort of idea what we're doing now.
Or more questions, But that was awesome, Katie. We do have one question from the audience.
Yeah.
are merges atomic operations. And if you
Hmm.
need me to kind of, hey, Graham, if you're listening, I'm going to unmute you. I don't know if you're on, well, it doesn't seem I can unmute you, but if you can write me back real quick to kind of clarify what you mean. Let's see. I
Yeah, I'm
don't,
not sure like what it means. Like,
well, I think he means granular, like atomic, like, but I can't speak for him. So let's see if Grim can clarify here in a second. And Katie, where we can find you at K Seiler, you or at or and sorry, of course that's some coding. Um, oh shit, get which I love. Um, and let's see if Graham. Katie, do you have anything else to say while we wait for Graham to maybe get back to us here on specifying what he means by atomic operations? Katie, are you there? Hello? Well, I think we just lost Katie. So Graham, uh, ping Katie at K Seiler or at Oh Shit Get, which is an amazing name. Um, and everyone else, please keep watching the Commitmiss shows that we have, and of course, all year round we have a ton of vBrownBags. So we appreciate your attendance. We appreciate you guys downloading the episodes or the shows. And stay tuned because we're going to be around for a while. So we appreciate the listenership. Thank you.